Monte Carlo tree search is a more sophisticated variation of Monte Carlo search that tackles some of the weaknesses of the simpler method. Both methods build up a game tree incrementally, and both rely on random simulation of games, but they differ in the way the tree is expanded. MCS, Monte Carlo search, uniformly expands the partial game tree during its expansion phase and then simulates games starting at the states on the fringe of the expanded tree. MCTS, Monte Carlo tree search, uses a more sophisticated approach in which the processes of expansion and simulation are kind of interleaved. MCTS processes the game tree in cycles of 4 steps each, and after each cycle is complete, it repeats the steps so long as there's time remaining, at which point it selects an action based on the statistics it's accumulated to that point. On the selection step, the player traverses the tree produced thus far to select an unexpanded node of the tree, making choices based on visit counts and utilities stored on nodes of the tree. We'll see how that happens a little bit later. During expansion, the successors of the state chosen during the selection phase are added to the tree. The player then simulates the game, starting at the node chosen during the selection phase. In so doing, it chooses actions at random until a terminal state is encountered, as with MCS. And finally, the value of the terminal state is propagated back along the path to the root node, and the visit counts and utilities are updated accordingly. Here's an implementation of the MCTS selection procedure. If the initial state has not been seen before, in other words, 0 visits has not been seen before, then it's selected. Otherwise, the procedure searches the successors of the node. If any of them have not been seen, then one of the unseen nodes is selected. If all the successors have been seen before, then the procedure uses the selectFn subroutine, which we'll talk about, to find values for those nodes and chooses the one that maximizes this value. Okay, one of the most common ways of implementing selectFn is what's called UCT, which is short for upper confidence bounds applied to trees. Typical UCT formula is shown here, VI plus the square root of log NP over NI. VI is the average reward for that state that it's seen so far. NP is the total number of times the state's parent was picked. And I is the number of times this particular state was picked. Of course, there are other ways that one can evaluate states. The formula here is based on a combination of what's called exploitation exploration. Exploitation here means the use of results on previously explored states, which is the first term, VI. Exploration means expansion of as yet unexplored states, a measure of which is the second term. And at the bottom of the slide we have simply an implementation of the formula shown at the top. Expansion in MCTS is basically the same as that for MCS. An implementation for a single player is shown here. On large games with large time bounds, it's possible that the space consumed in this process could exceed the memory available to a player. In such cases, it's common to use a variation of the selection procedure in which no additional states are added to the tree and just probes are used. Simulation for MCTS is essentially the same as simulation for MCS, so the same exact procedure can be used in both methods. MCTS, however, has a different procedure for recording the results. It's called backpropagation. At the selected node, the method records a visit count and a utility. The visit count in this case is 1, since it's a newly processed state. The utility is the result of the simulation. The procedure then propagates to ancestors of this node. In the case of a single-player game, the procedure simply adds 1 to the visit count of each ancestor, and it augments its total utility by the utility obtained on the latest simulation. In the case of a multiplayer game, the propagated value is the minimum of the values for all opponent actions.